In the transportation problem, this helps in minimizing the cost of transportation between the source and the delivery point. It is minimization. Convert it into maximization by multiplying by negative sign. The standard form of the given problem is max z is equal to 3x1 plus 3x2 plus 0s1 plus 0s2. So you can find out delta j. Delta j is equal to zj minus cj or cj minus zj. Hello dear students, welcome to this session of Operation Research or question paper solving session. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed part A, that is 2 mark questions. Now in this session, I am going to discuss regarding part B, that is 7 and 8 mark essay type questions. Now let us come to part B. In part B, the first question is question number 13, which contains A1 and A2. So in A1, explain the application of management where the tools and techniques of operation research are used. So what techniques? Explain the application management where the tools and techniques of OR operation research is applied. So this is 7 marks. So we are going to discuss the application management. Right. Now let us come to, there are so many applications. Let us discuss one by one. Now, management application of OR. Some areas of applications are finance. In finance, budgeting and investment cash flow analysis, investment portfolios, credit policies, account procedures can also be done using this operation research. So that is in finance, budgeting and investment, cash flow analysis, investment portfolios, credit policies, account procedures can also be done using the concept of operation research in finance. Whereas in come to the purchasing, procurement and the exploration. So rules for buying, supplies, quantities and timing of purchase, replacement policies can also be done using the concept of OR. So here the rules for supply, buying, quantities and timing of purchase, replacement policies can also be done using the concept of this operation research. Production management. In production management, so in production management like physical distribution and facilities of planning facilities, manufacturing and also maintenance and project scheduling can be done with the help of this OP. This is very important. That is production management. In production management, physical distribution and the facilities planning, manufacturing as well as maintenance and project scheduling can be done with the concept is this OR. Now very important application is OR, that is selection of the product as well as the timing. So these are the few application of management where tools of OR is used. This is very important concept. Now let us come to the next question. What is the next question? Same in 13A2. The second question is explain the principles of modeling. Explain the principles. So we have to explain the different principles of the modeling. Now here principles of modeling, that is the model building and their use, both should be consciously aware of the following 10 principles. Principles of modeling, the model building and their users should aware of the following 10 points. So there are 10 points. These 10 points are very important for building a model. Now what is the first one? Do not build up a complicated model when the simple one will suffice. So here, do not build up a complicated manner when the simple one will suffice. Now, beware of modeling the problem to fit the technique. So, beware of modeling the problem to fit the given technique. Now, the deduction phase of modeling must be conducted rigorously. The deduction phase of modeling must be conducted rigorously. The model should be validated prior to the implementation. This is very important concept. Models should be validated before implementation, and a model should never be taken too literally. It should not be taken too literally. Now the next 6th point is A model should neither be processed and do not be criticized for failing to do that for which it was never intended. Should not be criticized. And beware of overselling a model. So we should be beware of overselling a model. And some of the primary benefits of the modeling are associated with the process of developing the model. So some of the important primary benefits of modeling are associated with processing the development of the model. And a model cannot be any better than the information that goes into it. And the last one is models cannot be replaced decision makers. This is very important. The models cannot be replaced the decision makers. So these are the few important principles of a good modeling. Okay. So there are 10 points. These 10 points you have to remember. Now these are the two questions. Now let us come to this. For this there is a choice question. The choice question is 13 B1 and B2. So explain the scope of operation research. So the question here is scope of operation research for 8 marks. So there are different scopes. Let me explain few. In the field of agriculture, in the field of finance, in the field of industry, in marketing, in LIC, we have the scope. So OR plays very important role in agriculture, in finance, in industries, in marketing, as well as in LIC. Let me explain one by one. So in agriculture, with the exploration of the population and consequent shortage of food, and every country is facing the problem of optimum allocation of land to the various crops in accordance with the climatic condition. And so therefore the optimum distribution of the water from various resources like canals for irrigation purposes, there is a need of determination of best policies under the prescribed restriction. Hence a good amount of work can be done in this direction with the help of this operation research. Okay, that is how we are going to apply the concept of OR in agriculture. That is optimum allocation of land for various crops accordance with the climatic condition, and also the availability of water from various resources like canals for irrigation purpose can also be studied with the help of this operation research. This is one of the major application of OR in industry. So that is one of the scope of this OR in agriculture. Now let us come to the second one, in finance. In finance, in these modern times of economic crisis, it has become very necessary for every government to have a careful planning for the economic development of the country. So for planning of economic development of the country, concept or OR plays very important. That is that OR techniques can be fruitfully applied. How we are going to apply? To maximize the per capita income per minimum resources. To maximize the per capita income for minimum available of resources. To find out the profit plan of the company. To find out the profit plan of a company. To determine the best replacement policies. To replace the best policies, we are going to use the concept of a OR. Right. Now let us come to the next point, that is in industry, how this OR plays in industries. So if the industry manager decided his policies only on the basis of his past experience, and a day comes when he gets retirement, then loss is occurred in the industry. This heavy loss can be immediately compensated by newly appointing young specialists of OR techniques in business management. Thus, OR is very useful in the industry director in decision making or in allocation of various limited resources such as men, machine and material, etc. arrive at the optimum decision. This is one of the important application in the industry. That is, if the manager decides his policies only on the basis of his past experience, there may be after his retirement, then there may be a heavy loss for the industry. So which can be immediately compensated by newly appointing a young specialist or a OR technician in the business management. Thus, war is useful to the industry director in deciding optimum allocation of various limited resources such as men, machine and materials to arrive at the optimum decision. This is one of the important application of war in the industry scope. Now let us come to the very important scope in LIC. War plays very important scope in life insurance corporation. Approach is also applicable to enable LIC officers to decide what should be the premium rate for various modes of policies. To decide the premium rate for different modes of the policies, this operation research is very useful. Again, how best the profit could be distributed in case of with profit policies. So how to, how the best policies could be distributed in cases of with the profit policies. Okay, these are the field where the OR key is applicable. Now let us come to the next question. Question B2 in 13B2, the second question in B2. Explain the application of linear programming. Now LPP, there are so many applications. Let me explain few. Personal assignment problem and transportation problem, optimum estimation of employees compensation, production management, marketing management. These are the fields where we are using the concept of a linear programming. Let me explain one by one. So personal assignment problem. How this LPP helps in personal management problem. Suppose if X number of workers have to perform Y number of jobs, an assignment of each person to a job has to be done such that the overall productivity is optimized. Okay, so the overall productivity for X and Y is optimized, whether it can be minimum cost or minimum time taken, or so to get the maximum profit. This linear programming formulation is very, very important. Now, whereas in the field of transportation problem, in the transportation problem, this helps in minimizing the cost of transportation between the source and the delivery point. That is, between the source and the destination, this will help to minimize the cost of the transportation. This is very important application. Whereas third one is the optimum estimation of employees compensation. So the object here is to determine the consistent plan on the employees compensation by taking into an account their salary, job and their experience and the ranking. This is also a very important application. That is, object here is to determine the consistent plan on employees compensation by considering the salary and job ranking, etc. Next, let us come to the production. Next point is the production management. In production management, this linear programming can apply to determine the product mix and assembly time balancing. So in production management, we are going to use to determine the product mix and also assemble time and the balancing. Now, next concept is marketing management. In marketing management, the linear programming problem helps in analyzing the effectiveness of the advertising companies, and also the time based on the available advertising media, and also it helps to salespersons to find the shortest route while traveling. So this is one of the important application. That is, in linear programming will help analyzing the effectiveness of the advertising companies as well as the time based on the available advertising media, and also it helps the person to find the shortest route while traveling. So these are few applications of a linear programming problems. Now let us come to the next question, question number 14. Next question, the question 14A. So this is a problem. Now here the one, you will get one formation of a linear programming problem. Another one is finding the solution using graphical method or simplex method. Now let us come to the first question, 14A1. A firm manufactures two types of products. So observe carefully. There are two types of products, A and B. There are two types of products, A and B. Sells them at a profit of rupees. What is the profit? Profit of rupees 2 and 3. Profit 2 on type A and rupees 3 on type B. Each product is processed on 2 machines C and H. There are 2 types of machines C and H. And type A requires 1 minute of processing time on G and 2 minutes on H. Type B requires 1 minute on G and 1 minute on H. So here the time given is type A requires 1 minute processing on G and 2 minutes, 1 and 2. Whereas B requires 1 and 1. So 1 and 2, 1 and 1. This is given time. So the machine G is available for not more than 6 hours and 40 minutes. So we have to convert 6 hours 40 minutes. While the machine H is available for 10 hours during the working day. Formulate the problem as linear programming problem. Here the problem is of maximization type. Since the profit should be always maximum. So it is a maximization type. Let us consider the decision variables as x and y or x1 and x2, and we can formulate the problem very easily. Now let us convert the time in, since it is in minutes, so therefore convert 6 hours 40 minutes. 6 hours means 6 hours 40 minutes can be written as 360 plus 40, that is 400 minutes. Okay, let us come to the solution. Let us define the decision variables as x and y. Let us consider the decision variables as x and y. So there are 2 machines A and B, and the availability of time. Consider the machine. So there are 2 products, product A and B. And what are the types of machines? We have 2 types of machines, machines G and machine H. Okay, what is the profit? That is given. Type A, for type A, the machine G will perform 1 minute and machine H will give 2 minutes, and for machine B it is 1 minute, and for machine H it is 1 minute, and the total available time is 6 minutes, 6 into 600 minutes, that is nothing but 400 minutes, and 10 hours is nothing but 600 minutes. So one is 400, another one is 600 minutes, and what is the profit for A is rupees 2 and profit B is rupees 3. So hence we can write the mathematical model for this is since it is an objective function is of maximum type, so therefore max z is equal to 2x plus 3y, 2x plus 3y, subjected to the constraints. What are the constraints here? So for machine G and H, the product A and B, so we are going to take x plus y, that is x plus y, maximum available time is 400, less than or equal to 400. So x plus y is less than or equal to 400. Whereas for this machine B, H is 2 minutes plus 1 minute can be written as 2x plus y is less than or equal to 600. So hence the mathematical model for this problem is, LP model is max z is equal to 2x plus 3y subjected to the constant x plus y is less than or equal to 400 and 2x plus y is less than or equal to 600, and the non-negative restrictions are x and y is greater than or equal to 0, x is greater than or equal to 0 and y is greater than or equal to 0. That's it. This is how we are going to form the given LPP model. Very simple. Definitely you will get this type of questions. So don't miss, attend. Definitely you will get full marks for this. That's it. Just define the decision variables as x and y or x1 and x2 and just go to the problem. Then you can easily formulate the LPP problem. Now let us come to the next problem. Solve the given LPP using graphical method. So we have to solve this using graphical method. Now let us convert. What is the problem given? Max z is equal to x1 plus x2 subjected to the constraints x1 plus 2x2 is less than or equal to 2000, x1 plus x2 is less than or equal to 1500 and x2 is less than or equal to 600, x1, x2 is greater than or equal to 0. So or less than or equal to type. Now let us convert the inequalities into equalities first. So the given equation can be written as, the given equations are x1 plus 2x2 is equal to 2000. Another one is x1 plus x2. x1 plus x2 is equal to 1500. Another one is x2 is equal to 600. These are the values given. So convert these inequalities into equalities. This is line 1 for the first line, and the second line, line 2, and the third line, equation number 3. Now put x1 is equal to 0, you will get 2x2 is equal to 2000, x2 is equal to 2000 by 2, this is equal to 1000. So therefore, let us consider the first point as a, 0 comma 1000. Now again put x2 is equal to 0, you will get x1 plus 0 is equal to 2000. Therefore, x1 is equal to 2000. Therefore, the point B is equal to x1 comma x2 2000 comma 0. This is the first point. Now, let us come to the second equation. Put x1 is equal to 0, x2 is equal to 1500. Therefore, the point C is equal to 0 comma 1500. And put x2 is equal to 0, you will get x1 is equal to again 1500. Therefore, the point D is equal to 1500 comma 0. So, you can take C, D, E is equal to x2 is less than or equal to 0, 0 comma 600. This is the point. Now, these are the points A, B, C, D. Now, let us represent this on a graph sheet. Let us take a suitable graph on x and y axis. On x axis and y axis, this is x axis and y axis, or x1 and x2. Take a suitable scale and draw the graph. So, I will draw the graph here. So, this is the graph. X is equal to 0 and y is equal to 1000. That is 0 comma this for first curve, and 200 comma this is the first curve we are going to get. This is line 1. And similarly for the line 2, what are the points we have? 0 comma 1500 and 1500 comma 0. So this is for the line, that is for the line 2, that is line 2. Okay, and since x2 is equal to 600, so these are the corner points. So these are the corner points where the curve will meet. So the corner points are 0 comma 0, 0 comma 600, 800 comma 600 and 1000 comma 500, and this point 2000 comma 0. Now here at corner points, at corner points O, let us consider this as E, O, E and D, then C and A. Write down the values. At O, what is the objective function? Here it is max z. Z is equal to x1 plus x2. Now at 0 comma 0, z is equal to 0. Now at this point, let us come to the first point A. A is equal to A at a 1500 comma 0. Z is equal to 1500 plus 0, that's equal to 1500. Again at C is equal to 1000 comma 500. Therefore, Z is equal to 1000 plus 500, that is also equal to 1500. Again at D, what is the point D? 800 comma 600. Z is equal to, what is the objective function? X1 plus X2, 800 plus 600. 800 plus 600, that's equal to 1400. Now at last point E, at E 0 comma 600, at E 0 comma 600, Z is equal to 600. Right. So what is required to find is, so using maximum Z. So what is the maximum value? Here the maximum value is, this is the maximum value and this is the maximum value. So there are two maximum values, 1500 and 1500. Two maximum values are there. Therefore, Z maximum is equal to 1500 at what are the points? One point is 1000 comma 500. Another one are at Z is equal to A at A 1500 comma 0. So therefore the maximum value is 1500 at 1000 comma 500. Another one is 1500 comma 0. That is how we are going to solve this linear programming problem. That's it. Okay. Now let us come to the next problem. So 14, in 14 B1. So the choice for this is B1. So explain the computational procedure for big M method for the solution of a maximization of a linear programming problem. Now let me explain the step-by-step procedure to solve LPP using Big M method. Now steps in Big M methods, or it is also called as penalty method. So if the problem is minimization type, convert it into the maximization type by multiplying the objective function by -1. So first, so if the given problem is minimization, if it is minimization, convert it into maximization by multiplying by negative sign. And the second point, in any of the constraints in the RHS, if the coefficient is negative, make it positive by multiplying both sides of the constant by negative sign. This will, of course, change as the inequalities sign, like less than or equal to, greater than or equal to, or greater than or equal to less than equal to. Next, in the constraint, introduce the slack and surplus variables and artificial variables on the left hand side to convert the constraints into equality. So in the constraint, introduce the slack variables, slack and surplus variables like S1 and S2, and the artificial variables like A1, A2, and etc. If the constraint is less than or equal to, add only the slack variables. This is very important. If the constraint is less than or equal to, add only the slack variables on the left hand side. If the constraint is of the form greater than or equal to, subtract the surplus variable and add the artificial variable on the left hand side. If the constraint is equal to, add only the artificial variable on the right hand side. Okay, these are very, very important points. We are going to use the step-by-step method to solve the problem using Big M method, right? Now, let us come to the next problem in this. The very important problem is, consider the LPP max z is equal to 3x1 plus 2x2 subjected to the constraints x1 minus x2 is less than or equal to 2, where x1, x2 is greater than or equal to 0. Solve by Simplex method. The first one is step-by-step procedure for Big M method. Now this is Simplex method. Very simple, construct the initial basic table and just perform the operations. That's it. Now let us write the standard problem. The standard form of the given problem is max z is equal to 3x1 plus 3x2 plus 0s1 plus 0s2. That is, just add the slack variables. S1 and S2 are the two slack variables is to be added for the objective function whose coefficients, whose initial cost is 0 and 0. Let max z is equal to 3x1 plus 2x1 plus 0s1 plus 0s2 subjected to the constraints. By converting the inequalities into equalities, we will get x1 plus x2 plus s1 is equal to 4, x1 minus x2 plus s2 is equal to 2, where s1, s2, x1, x2 are all greater than or equal to 0. Just write down the coefficient and find the initial vector for this. So x1, x2, s1 and s2. The coefficients for the first equation is 1, 1, 1 and 0. For the second equation, it is x1 is 1, x2 is minus 1, s1 is 0, s2 is 1. So this will form the identity matrix. So we can start with s1 and s2. Okay. Now let us come to the initial simplex table. In the initial simplex table, the basic variables are s1 and s2, whose coefficients are 0 and 0. Write down the coefficients of the basic variables x1, x2, s1, s2. The coefficients are 3, 2, 0, 0, 3, 2, 0, 0. The solution, ratio and the solution. Now write down the coefficients for these two equations, that is 1, 1, 1, 0, 1, 1, 1, 0 and 1 minus 1, 0, 1, 1 minus 1, 0, 1 and the values are 0, 4 and 2. The ratios are 4 and 2. Now let us find out, just find out the value of Zj. Zj is equal to, just multiply this. So 0 into 1 is 0 plus 0 into 1 is 0. Again 0 into 1 is 0 plus 0 into minus 1 is 0. Again 0 into 1 is 0 plus 0 into 0 is 0. Again 0 into 0 is 0. 0 into 1 is 0. Just multiply all the elements. Now find out Zj. So you can find out delta j. Delta j is equal to Zj minus Cj or Cj minus Zj. Right. Okay. Now here, so Cj minus Zj, this is delta j. Delta j is equal to Cj minus Zj. Cj minus Zj. What is Cj here? This is 3 minus 0, 2 minus 0, 0 minus 0. Here all the values are positive. Just consider the maximum positive value as the incoming variable, right? Suppose if we consider Cj minus Zj, the least negative you are going to consider. Okay, here maximum value is plus 3. Therefore, this is the incoming variable. 1 and x1 is the incoming variable. Now find out the ratio. How to find the ratio? So the ratio is given by x0 divided by x1. x0 divided by x1. That is 4 divided by 1. 2 divided by 1 is equal to 4 and 2. Okay. Since here the least positive value. What is the least positive value? This is the least positive value. Therefore, this is the outgoing variable. Let us represent this as the outgoing variable. So here incoming variable is x1, outgoing variable is x2. Now, just in the next iteration table, just s2 is replaced by x1. I will go for this. And again, what is the intention? Find out the key element. The intersection of the row and column is called the key element. Here 1 is the key element. This is 1 and the remaining element as 0. Already this is 1. No need to change, and convert this element as 0 in the next iteration. For that, we are going to use the operation row and column operation, right? R2 dash is equal to R2 minus R1 and R1 dash is equal to R1 minus R2. Using that elementary row operation, let us convert this 1 as 0 and we can go for the next iteration. That is, in the iteration, if you apply the formula R1 minus R2 is equal to 0, we are going to get S1 is replaced, S2 is replaced by X1 whose coefficient is 3. And see, similarly find out the value of Zj. 0 into 0, 3 into 1 is 3, 0 into 2, 3 into minus 3 is minus 3. Again, 0 into 1 is 0 plus 0. Again, 0 into 1 is 0, 3 into 1 is 3. And the solution we are going to get. Similarly, find out the maximum value here is, this is the incoming variable. This is incoming variable, and find out the solution. Here also x0 divided by x2 is the ratio, that is 2 divided by 2, and 2 divided by minus 1 is 1 and minus 2. The least positive value is 1, so ratio is 1. Therefore, this is the outgoing variable. So the key element is 2. Right. Now, since let us go to the next iteration table, the second iteration table. Convert these two as 1 and simplify. So then you are going to get all the values. Cj minus Zj is negative. So therefore the optimality is reached. And the optimal solution is, what is the optimal solution? X1 is equal to 3 and X2 is equal to 1. The maximum value you are going to get is 11. So therefore the optimality is reached at this point because all the values in Cj minus Zj are negative. Hence the optimality is reached. So x1 is equal to 3 and x2 is equal to 1. Substitute here in the objective function. Max z is equal to 3x1 plus 2x2. 3 into 3 plus 2 into 1, that is 9 plus 2 is equal to 11. So the maximum value is 11 at x1 is equal to 3. x1 is equal to 3 and x2 is equal to 1. So x2, yes, x1 is equal to 3 and x2 is equal to 1 and the maximum value is 11. This is how we are going to solve the problem using simplex method. Okay, I have explained all these type of problem in concept class. Just go through these type of problems. So definitely it is very useful for you to solve the problem. Right. So that's all regarding this session. Let us meet with the remaining problems in the next session. That's all. Thank you. Thank you very much.